Today I'm going to talk about LeetCode question number 70, climbing stairs. So you're climbing the staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. How many distinct ways can you climb to the top? So for example, there are 2 ways to climb to the top, 1 plus 1, and obviously just 2 steps. And with n equals 3, there are 3 ways to climb to the top, 3 1 steps, a 1 step and a 2 step, or a 2 step and a 1 step. So how do we go about this problem? So let's say n equals 6. Okay, let's say n equals 6. How do we go about it? So we're at step 0 right now, okay? And we have a choice to make. So we can either go 1 step or 2 steps, okay? And from these steps, so right now we're at the first step, and then here we're at the second decision, we're at the second step. So from these, we can either go 1 step again, so give a total of 2, and then or 2 steps to make us at the third step here. Okay, and here, similarly, we have decision tree. We can branch this decision tree and go plus 1 step, which makes us go to 2 here, and 4 plus 2 make us go 4. And pretty much same thing, so I'm going to quickly write it out. And here similarly for this is 5, 6. Let's just leave that n equals 5 for now, just for brevity. Okay, so for at the 0th step, what are the combinations where we can get to the 5th step here? So there's 1, 2, 3, and I actually didn't finish this decision tree, so here. And this would be, yeah, and same thing here. It's going to be a lot. So for example, we have this, 1 path, a 2nd path, a 3rd path, 4th path, 5, 5th, 6th, etc. And there's more here that I didn't draw out. Okay. So we could do that. We could compute all the possible ways using this decision tree here. It would be basically kind of a depth first search here. We explore all the decision branches in this tree. But this is quite efficient because just look. So right now we're at 1 node here. In the second layer of the tree, we have 2. In this third layer, we have 4. And then 1, 2, 3, 4, 5, 6, 7, 8, and etc. So this is coming out to be 2 to the n runtime. This is exponential. 2, 0, 2, 1, squared, 2 cubed, etc. And this is quite inefficient. So how do we make it better? Notice how we have a bunch of repeated work here. So for example, if we want to compute the number of paths we have at the 2nd step, we're computing it multiple times really. Okay, and similarly for the 4th step, we're computing that multiple times. So why not save these results? Okay, and saving these results for future use is known as memoization. Okay, basically you save a computation result, and if the result is present, we usually store it in a dictionary or hash map. If they're present, then we use that. If not, then we compute. So this is the concept of memoization. And yeah, we can use that first search with memoization here. And this would bring the runtime back to O of n. But to have this be a true dynamic programming solution, I suggest instead of going from this top bottom here, why not go bottom up? Compute the bottom results and use them in this top result here. Okay, so basically how that's going to go is we're going to have an array. So this is a 0 step, first, second, third, fourth. Okay. Okay. And basically our base case at the 5th step is 1 here. Okay. And then with the 4th step, actually I kind of find it easier to do it the other way. Or actually this way is good too. But yeah, okay. For 5th here, you have 1. Okay, 4th step, how many ways can we have it where we reach 4? So the question says we either climb 1 or 2 steps, so we look 1 ahead and 2 ahead. So 1 ahead is 5 and 2 ahead is obviously nothing, so we have 1. And what about this guy here? We look 1 ahead and 2 ahead, and we add these together, 2. And similarly, it would be 1 ahead, 2 ahead. It'd be 3 and 5 and then 8. Okay, so yeah, that's basically how that goes there. Another way to have it is instead of like starting from 5 at the very end there, you can start with like, I kind of find it easier to visualize this way, where we start at 0, 0, 1, 5. And same thing, base case is 1 here. Okay, and then first step, we obviously only have 1 way to get up here. And then with the second step, we look previously at the last 1 and the last 2 and add them together. Okay, and then third step, we look at the previous 1 and previous 2, add them together, and so on. And I kind of find it a little bit easier to visualize this way, that, okay, if we want to reach the 5th step, there's 8 ways. With the 4th step, there are 5 ways, etc. And I'm probably going to do it this way. Runtime is O of n. And also, we don't need to use an array to store all this information. So if we think about it, we're only storing the previous 1 and the previous 2nd value. So why not just store the previous 1 and the previous 2nd value into just simple variables? So yeah, instead of an array, we're just going to use 2 variables, and it's going to be constant memory. Okay, to code this up, so I already defined my recursive function here with memorization, in case you're curious, but I want to kind of treat it to do it the proper dynamic, bottom-up dynamic programming way. So what I'm going to do here is initialize 2 variables. So 1 step behind is going to be equal to 1, and then 2 step behind is going to be equal to 0. Okay, so this 1 step behind initially is going to represent us at the first step, and this guy is going to be out of bounds. Okay, so now for I in range so that's out of bounds us at the 0th step, or base case actually, as I should say. So I range 1 and n plus 1, because we want to get all the way up to n here. What we're going to do is set temp variable to be equal to 1 step behind, and then we're going to update 1 step behind to be equal to itself plus 2 step behind. So currently at position 1, this will be equal to 1 step behind and 2 step behind, and then for our next iteration we're going to update 2 steps behind to be temp. And finally what we're going to do is turn one step behind. Okay, so I'll try running that code here. Okay, now submit. Okay, great, thanks for watching.